Welcome back to the deep dive, where we take the sources you shared and turn, well, complex technical documentation into pure, focused insight. If you've ever wanted to really understand the foundational architecture of Haskell projects, then today is definitely your day.
It is.
We're diving deep into a stack of research all about Cabal. That's the standard build system and package manager that really acts as the engine room for just about every Haskell application out there.
Right.
And our mission really is to take the most confusing moment in the Haskell development lifecycle, that initial project setup, and turn it into an absolute architectural aha moment about reusability and dependency management.
And that moment, when you first run that setup command, it can really feel like you've been dropped into some kind of engineering exam.
Yeah, it really can.
But trust us, every single question Cabal asks you at the start is designed to enforce quality control and future scalability. We're going to decode those early decisions, because if you understand why you're structuring your project a certain way, you save weeks of headaches down the road.
Okay, let's unpack this setup.
Let's get right into the project lifecycle.
So let's start with the operational big picture. When you work with a compiled language, you need a full toolkit to go from, an idea to a globally installed application. The complete life cycle for building and managing a Haskell app really revolves around 4 core command line steps in Cabal.
We're calling them the 4 pillars.
The 4 pillars, exactly. And the first, which is the focus of our deep dive today, is Cabal init.
The initialisation step.
Right. It's where you define the project's intent. Is it a library? An executable? Both. This command creates that crucial blueprint, the structure, and the .cabal configuration file.
So once that structure is defined, you move to the compile step.
Yeah.
Cabal build.
Yep.
This is where Cabal reads your .cabal file, figures out all your internal and external dependencies, downloads anything that's missing, and then, compiles everything into machine code. It's the essential translation step.
Absolutely. Now, what do you do during development? You certainly don't want to run build every single time you make a change.
No, that would be a nightmare.
That's where the third command comes in, and this is your day-to-day workhorse, Cabal run.
Right.
And typically, Cabal run is smart enough to handle the full cycle for you. It checks if anything needs to be rebuilt, compiles only what's changed, and then immediately executes your application.
It's fast, it's efficient, and it's perfect for testing code changes in real time.
Exactly. And the final pillar, once everything is polished and ready to go, is Cabal install.
This is the distribution step. This command takes the final executable you just built and copies it to a global location in your system's path.
Which means you can type the name of your application, let's say we call it fish, anywhere in your terminal and
Just runs.
It just runs.
Now, if you've been working in other modern compiled languages, say Rust, for example, this command set probably feels very familiar.
Very familiar.
You have your cargo init, cargo build, cargo run, cargo install. It's a standardized, effective approach to managing a whole language ecosystem.
But here is exactly where the comparison stops being a straight parallel. A simple cargo init usually just assumes you want a standard binary application, maybe with a library alongside it.
Right.
Cabal, on the other hand, right out of the gate, demands much more specific structural clarity from you.
That is the key distinction. Haskell's entire philosophy is rooted in structural integrity and purity. The minute you run Cabal in for a new project, you are forced to make these big architectural decisions that other tools let you just put off.
Yeah, defer until later.
If you try to bootstrap a project, you're immediately asked this crucial question that could define the next year of your project's life.
That instant demand for clarity is exactly what trips up so many developers new to the Haskell world. You just want to start writing functions, but Cabal stops you and says, hold on, what exactly is this project supposed to be? The core prompt is, what does the package build?
And Cabal doesn't offer a one-size-fits-all answer here.
Not at all. It gives you 4 distinct choices that really define your project's DNA and its relationship to the whole ecosystem, especially Hackage, the Haskell package repository.
Okay, so what are the options?
The options are a library, an executable, a library and executable combined, or a dedicated test suite.
And when you look at those choices, the first 3 make a lot of logical sense. You build a reusable component or a standalone app or both. But that 4th option, the dedicated test suite package, that immediately raises a really fascinating architectural red flag.
It does, doesn't it?
Yeah, why would you create a package solely for testing, separate from your main application or library? Most ecosystems just bundle tests inside the project structure.
Exactly.
And if we can understand the architectural implication of this isolated test component, I think we unlock the core insight of why Cabal forces these distinct setup options on you in the first place.
That is the exact question we need to answer. And to do that, we have to stop looking at these as just, bullet points in a menu. We have to start looking at the structure they generate, because the directory structure is truly a blueprint of the project's future intent.
Okay, so let's walk through them.
Let's guide you through the first two options, which really represent two opposing architectural goals. Let's look at the library option first. If you choose this path, you are signaling to the world, this project is intended for maximum reusability. It's an API, it's a framework, a foundational piece of logic meant to be imported by other projects.
It's a package for hackage.
It's a package for hackage, precisely. And when you initialize a library, the directory structure is very specific. You'll find all your production code lives in a directory called SRC.
Right.
This is where the core reusable logic lives, clearly separated from any kind of entry point or testing files.
And that SRC directory is so critical because it forces developers to think about their public interface. If you put something in SRC, you are inherently declaring this is the set of functions and types that other projects are going to depend on.
It's a contract.
It is. It promotes purity and a really well-defined API boundary.
Okay, now let's contrast that with option 2, the executable.
A completely different philosophy. When you choose this, you're telling Cabal, I don't care about reusability right now. This is a simple, standalone console tool meant to do one job and be run immediately.
Think of it like a wrapper script, maybe. It just calls a complex API or performs some little utility function. It's optimized for running, not for being imported.
Right.
So architecturally, the executable option just skips that whole reusable component idea. Instead of SRC, your code lives in an app directory, specifically in appmain.hs.
And the separation of SRC and app is so important here. It clarifies that the code in app is the entry point. It's the messy operational code that glues things together.
While all the ideal reusable logic belongs in SRC.
Exactly. And for simplicity, the executable template often doesn't even set up a dedicated test scaffolding initially, because the immediate intent is just pure execution. This is for the developer who just needs that quick utility script.
Right.
It sacrifices that long-term component reuse for maximum immediate simplicity.
So to sum that up, if you're trying to build a new standard library, you choose library. If you're building a quick tool to, say, automate some file renaming on your system, you choose executable.
Two very clear, very different architectural intents.
Established just by the presence or absence of that SRC directory.
Yep.
Now we get to the standard workhorse option 3, library and executable combined.
This is generally the recommended path for developing a serious, production-ready console application. It gives you the full package.
The best of both worlds.
It is. And this is the structure you see in major Haskell applications. And why is that? Because you separate your application's entry point, appmain.hs, from your application's core logic, src_mylib.hs.
So the executable is just a consumer of its own library.
Precisely. The executable just imports the functions it needs from its own internal library component. And this enforces good hygiene. All your complex algorithms, your data structures, your pure functions, they all live in the library component, which can be unit tested in isolation.
And the executable component becomes just a thin layer that handles things like command line arguments and orchestrates the library calls.
Yeah, all the messy I/O.
Exactly. It's the best of both worlds because you get the executable for distribution and you get the reusable library component for future projects or even for integrating with other tools down the line.
And it sets you up with a testing component right there, ready for basic unit tests.
Right. But this brings us back to that mysterious fourth option, the isolated test suite. If option 3 already provides everything, library, executable, and tests, why would Cabal even give you an option 4, a package only for testing?
Option 4, the isolated test suite, is reserved for packages that have a single specialized purpose, validation. We are talking high-level integration tests, full system tests, or performance benchmarks.
It's a dependency firewall.
That's the perfect way to put it. It exists to create a dependency firewall.
Okay.
And structurally, it's startlingly minimal.
It is.
It only contains the test component ready for a main.hs file, but it completely lacks the app or SRC directories. It's architecturally focused only on validation, proving that something else, which could be a different Cabal package, entirely works.
Okay, so here's where it gets really interesting and where we deliver on that aha moment.
This is the deep dive. Why do we need two different ways to test? Why risk the hassle of managing a whole separate package with option 4 when option 3 already bundles a test component right inside the standard structure?
Let's break down the technical mechanism Cabal uses. Unlike some build systems that just dump all dependencies into one huge project file, Cabal manages dependencies per component.
That's the key.
The dependencies for your library are distinct from the dependencies for your executable, which are distinct from the dependencies for your test suite.
And this difference highlights the central philosophy of dependency isolation in Haskell. Imagine your core library only requires, say, 4 dependencies, basic parsing tools, and maybe a logging utility.
Okay, super clean.
Right? Clean, easy to audit, fast to compile. Now, imagine you need to run complex integration tests. These tests might require a massive set of specialized tools. A database driver like PostgreSQL, a comprehensive network mocking library.
Or even external bindings to graphics libraries or specialized hardware like a GPU driver.
Exactly. Huge, heavy dependencies.
So if you use the standard structure, option 3, for those complex tests, all those heavy dependencies, the database drivers, the networking libraries, potentially gigabytes of testing tooling, they get added to the overall project dependencies.
And even though they are component-specific, the project itself still lists them. It gets messy.
It does. But by creating a separate, isolated test suite package, that's option 4, you completely firewall those large, complex dependencies.
The core library package remains pristine. It's clean, and it's dependent only on those 4 simple things. The huge, complex testing tools live outside in their own quarantine package.
And what this means for you is efficiency, purity, and maintainability.
Right. It keeps your core library's dependency footprint minimal, which makes it extremely easy for other developers to integrate your code without inheriting a massive testing infrastructure they don't even need.
It's an exercise in architectural hygiene.
That really echoes the pure function philosophy of Haskell itself.
So when should you pick which one? It sounds like you should generally use the built-in testing component of option 3 for your unit tests and simple property tests.
Absolutely. These are the tests that verify the internal integrity of your code using minimal standard dependencies.
And you should reserve option 4, the isolated test suite package, for those complex, high-overhead tests.
If the test requires connecting to a live database, spinning up external network resources, or using specialized operating system libraries, that's when you reach for option 4. You isolate the complexity, preventing dependency pollution of your core production code.
This structural rigor ensures that the components you design for reuse are genuinely lightweight and pure. And that brings us back to our core takeaway. The initial choices you make when you run Cabal init are far from arbitrary.
Not at all.
They are fundamental architectural decisions that dictate the intent, the reusability, and the dependency burden of your entire Haskell project. The directory structure isn't just a place to put files, it's a meticulously designed blueprint for development intent.
Absolutely. And understanding this structural purity is just paramount in Haskell development.
Yeah.
It's all about being deliberate.
Right.
And when you compare this process to ecosystems that favor a highly flexible, sort of one-size-fits-all project generation approach, where dependencies are often mixed freely, you really see the trade-off.
A very clear trade-off.
So considering this strong emphasis on dependency, isolation, and structural purity, how might this philosophy affect the speed and overall maintainability of extremely long-term enterprise-scale projects in comparison? That's something fascinating for you to mull over as you start your next structurally pure Haskell project.
A perfect provocative thought to end on. We hope this deep dive helps you navigate those initial steps with a lot more confidence. Until next time, keep learning.